Hey guys, so today we're going to talk about derivatives of exponential functions. So far, anytime that we took the derivative of a function, the variable was in the base of that function. So something like f of x is equal to x squared plus 5x. And we could just apply the power rule and say that our derivative was 2x plus 5. Again, that variable was in the base. The variable is in the base. What we're going to start looking at now is when the variable, the x, is in the exponent of the function. So say I take the function f of x is e to the x. So again, that variable is now the exponent. The derivative of e to the x is just e to the x. Super simple. So let's do a couple of examples with that. If I have the function f of x equals x squared plus e to the x, since my function is split up between addition, I can just apply my derivative to each term, whatever derivative rule applies. So over here, my variable is in the base. So I use my regular old power rule. That becomes 2x. Over here, my variable is in the exponent, and we just figured out that the derivative of e to the x is e to the x. So the derivative of this function is 2x plus e to the x. Number 2. F of x equals x cubed times e to the x. So since these two terms are not separated by addition or subtraction, I can't just take the derivative of each piece individually. Since I'm multiplying these two terms, I have to use the product rule. So x cubed is going to be my first, and e to the x is going to be the second. So remember, the product rule says first times derivative of the second plus second times derivative of the first. So that means f prime is going to be first x cubed times the derivative of the second. The derivative of e to the x is e to the x, plus the second, e to the x, times the derivative of the first. When I do the derivative of x cubed, I'm just going to use the power rule. So that's going to give me 3x squared. We're not going to worry so much about simplifying these, so I'm going to stop right here. I know that if I have a function f of x equals e to the x, that the derivative of e to the x is e to the x. Now, what if I have something else in that exponent? What if that exponent is x squared or x cubed or x to the fourth plus 5x? We could then write that function as e to the u, where u is a function of x. It's just a whole bunch of x's. If I take the derivative of e to the u, I'm essentially applying the chain rule for an e to the x derivative. So my derivative for e to the u is going to be e to the u times du dx. In words, we like to say that this is copy times the derivative of the exponent. Let's do a couple of examples. Number 1, f of x equals e to the 3x cubed plus x squared. Since my two terms are separated by an addition sign, I can take the derivative of each term individually. So I'm going to start off with the derivative of e to the 3x cubed. Since this exponent is not just a plain old x, it's a function of x, I need to use this rule here, e to the u du dx. So I'm going to copy and multiply by the derivative of the exponent. Copy e to the 3x cubed times the derivative of the exponent. I'm just going to use the power rule, so that becomes 9x squared. Plus, now I take the derivative of my second term. This is just a power rule. The derivative of x squared is 2x. Number 2. F of x is 2x squared plus 5 over e to the 4x. This over is telling me to divide, so I need to use the quotient rule here. Remember, the quotient rule is low times the derivative of the high minus high times the derivative of the low over low squared. So let's start setting up this derivative. F prime is going to be low, e to the 4x, times the derivative of the high. When I take the derivative of this numerator, I use the power rule here. I get 4x plus the derivative of 5 is 0. So good there. Minus high, 2x squared plus 5, d low. When I take the derivative of e to the 4x, I'm using this rule. Copy derivative of the exponent. Copy e to the 4x, derivative of the exponent. The derivative of 4x is 4. Whole thing over low squared. So that's e to the 4x squared. And again, I'm just going to leave this like this. I'm not so worried about simplifying this yet, so we're just going to leave this alone. Number 3, we'll do one last e to the u example. I see that I have e to the 5x cubed times cosine of 3x to the 4th. So I'm going to use the product rule here, where my first is e to the 5x cubed and my second is cosine of 3x to the fourth. I'm using the product rule, so I have first e to the 5x cubed times the derivative of the second. When I take the derivative of cosine of 3x to the fourth, I need to use a chain rule. The derivative of cosine is negative sine. That's the derivative of the outside. I leave the inside alone, 3x to the fourth, times the derivative of the inside, that's what's in the parentheses, is 12x cubed. So again, here was your first. This whole thing is the derivative of the second. Plus the second, cosine of 3x to the fourth, times the derivative of the first. When I do the derivative of e to the 5x cubed, I'm going to do copy times the derivative of the exponent. Copy e to the 5x cubed times the derivative of the exponent, 15x squared. And again, we definitely could clean this up a little bit, but we're going to leave it alone for now. The next function that we're going to take a look at is an exponential function of any base. So when we looked at the derivative of e to the x, that was a special exponential function where e was the base. So we had if f of x is e to the x, the derivative is e to the x. And if f of x is e to the u, then the derivative was e to the u du dx. So again, this is a special function where e is the base. What we're going to look at now is when the base is any number. And we're going to let that number be a. So this could be 2 to the x, 3 to the x, 4 to the x, pi to the x, any number to the x. The derivative of any number to the x is going to be a to the x times ln of a. Similar to e to the x and e to the u, if that exponent is different, it's not plain old x. If that exponent is x squared, x cubed, x to the fourth plus 6x, anything other than plain old x, then I need to use a kind of chain rule, and I'm going to let that exponent be u. If that's the case, then my derivative is going to be a to the u ln a du dx. In words, we say this one is copy ln the base, multiply by the derivative of the exponent. Let's do a couple of examples. Number 1, if f of x equals 2 to the x, this is this form. My exponent is plain old x, so my derivative is going to be a to the x ln a, or copy ln the base. So f prime is copy 2 to the x ln the base is 2, so times ln of 2. These ones, there's really never any simplification that you can do because of this ln of the base. It just makes things super complicated to really combine. So you're never going to have to simplify for these. Just leave them alone. And number 2, I have 3 to the x squared. So since my exponent is not plain old x, I have to use my chain rule form. So my rule here is copy ln the base, derivative of the exponent. So f prime is going to be copy 3 to the x squared, ln the base, ln 3, times the derivative of the exponent. The derivative of x squared is 2x. Number 3, x cubed plus 3 to the x cubed plus 2. Since these two terms are separated by an addition sign, I can take the derivative of each term individually. My first term, the variable, is the base, so I'm just using the power rule. The derivative of x cubed is 3x squared. For the second term, my variable is in the exponent. This is an exponential. So I have to use the a to the u rule. So the a to the u rule is copy ln the base times the derivative of the exponent. So copy 3 to the x cubed plus 2, ln the base, ln 3, times the derivative of the exponent. The derivative of x cubed is 3x squared, plus the derivative of 2 is 0, so I don't need to write that. Number 4. F of x equals x squared times 4 to the x squared plus 5. Since I'm multiplying here, I need to use the product rule. X squared is the first term. 4 to the x squared plus 5 is the second term. When I do the derivative, first, x squared, derivative of the second. This is a to the u. So I copy ln the base times the derivative of the exponent. The derivative of x squared is 2x. Plus the derivative of 5 is 0. I don't need to write that. Plus, now I'm going to finish my product rule. The second, 4 to the x squared plus 5, times the derivative of the first. The derivative of x squared is 2x. Just need to use the power rule there because the variable is in the base. Number 5, f of x equals e to the 3x squared plus 4 to the 2x minus x to the 5th. Since each of these terms are separated by addition and subtraction signs, I can take the derivative of each piece individually. When I do the derivative of e to the 3x squared, I'm using the e to the u rule. The derivative of e to the u is e to the u du dx. Copy times the derivative of the exponent. E to the 3x squared times 6x plus. When I take the derivative of 4 to the 2x, this is an a to the u. The rule for the derivative of a to the u is copy, ln the base, derivative of the exponent, minus, when I take the derivative of x to the 5th, this is your basic power rule. The variable is in the base. So the derivative of x to the 5th is 5x to the 4th. That's it for derivatives of exponential functions. If you have any questions, feel free to leave them in the comments below. Have a great day.